Hi everyone, welcome to 9.5 Estimating Decimals. Estimating has historically been very challenging for students. However, it really isn't if you follow some easy steps. Just like with whole numbers, you can estimate to decide what an answer to an addition problem might be. So you can estimate to kind of get an idea of what a total might be if you were buying something. So let's look at a money situation. Let's say you were at the store and you wanted to buy something that was $6.75 and something that was $15.45. You can round to the nearest dollar and get an estimate of how much this would cost. So when I say to the nearest dollar, that means to the nearest whole number. So we're looking at these two numbers to see where we can estimate it. We look at this to see which way we would go. And then we look at this. So let's look at the first one. If I have $6.75 and my choices would be $6 or $7 if I'm rounding to the nearest whole number, and here's 6.50, well, 6.75 would be here, so that's closer to 7. So it would round to $7. Another way to look at it is 7 5 or more? Yes. So that means the 6 is going to round to 7. So step 1, identify what two numbers you can round to. In this case, it was 6 and 7. And 2, look to the digit to the right to tell you which way to go. So since we knew this was between 6 and 7 is closer to the higher number, it would round to 7. So let's look at the strategy for 15 and 45 hundredths, or $15.45. If I'm rounding to the nearest whole number, I have two choices. I have 15 or 16. And when I look at the 4, that is 4 or below or less than 5. So I'm going to round down. So then I would round to 15. So now we can estimate that our sum would be 15 plus 7, which is 22. So $22 is our estimate for these two items. All right. If you have any questions, you can add them to the doc or email me. Let's keep going. So now let's look at a regular addition problem. So if I had 31 and 65 hundredths plus 8 and 2 hundredths, and of course we're going to line up those decimals while we're adding, I can estimate to see what the total is prior to doing the actual problem to make sure I don't make any mistakes. So that's a really good reason to estimate. And we call that, is my answer reasonable? Well, the estimate says, yes, my answer is reasonable if the estimate is close to whatever you get when you add. So let's look at this problem. 31 and 65 hundredths, well, we're going to look here. That's going to make it go up to 32. And 8 and 2 hundredths, the 0 is going to make it stay the same. So our estimate is 40. Now let's actually add. So 5 plus 2 is 7. 6 plus 0 is 6. Here's my decimal point. 8 plus 1 is 9. And 3 plus nothing is 3. Is my estimate close to my actual answer? Yeah, so we know that it's reasonable. Let's see if you guys can do it on your own. So here are a couple problems. I want you to line up the decimal, add these, but first estimate. So first estimate, then add them. So and then see if your estimates were reasonable. So this is the time you would pause, you would work on these, and then you'd come back to see if you got your answer correct. So I'm gonna go ahead and do these for you so you can see if you got it correct. So 3 7/78 would round to 4. 5 2/10 would round to 5. So my estimate is 9. Now if I actually add these up, I have to line up my decimal. So here's my decimal. I'm gonna actually move this over a little. There we go. We know that this is really like a 0 here. So 8 and 0 is 8. 7 plus 2 is 9. Decimal 5 and 3 is 8. So my actual answer is 8 and 98/100, and that is close to my estimate. So I got it right. Now let's try this one. 12 9/10 would round to 13. 3 26/100 would round to 3. So my estimate would be 16. Now let's go ahead and add. Make sure I line those decimals. And I'm putting zeros for placeholders. So 0 plus 6 is 6. 9 plus 2 is 11. Regroup. 5, 6, and 1, 16 and 16/100. That is definitely close to 16. So chances are I got that correct. Some mistakes you may have made if you didn't get this correct is, did you add correctly? Could be a simple mistake. Or did you forget to line up your decimals? Because that is often a mistake, which is why estimating comes in handy. It would show you that you did forget to line up your decimals. So this estimating thing is something that we really do in our head to kind of think, well, if I was going to add what these numbers are close to, does this make sense? Is this reasonable that I got these answers? So we can also estimate when we subtract. So let's look at our next problem. So if I had 7 13/100 minus 5 7/10, I can round again to the nearest whole number to find an estimate. So 7, it would be 7 or 8. That 1 tells me that it's 7. It would be 5 or 6. This 7 tells me that this is 6. If I subtract, I get 1. So my answer should be close to 1. Let's try it out. Make sure I line up my decimals. Put zeros for my placeholders. 3 minus 0 is 3. 1 minus 7. I can't do, I have to borrow or regroup. So I'm going to take 1 from the 7 and regroup it so that this becomes 11. So now 11 minus 7 is 4. And then 6 minus 5 is 1. So I get 1 43/100. And that is close to my estimate of 1. All right, let's try one more. So if I have 11 9/10 minus 9 and 23 hundredths, no, 9 hundredths, sorry. I have to make sure my decimals are lined up. And then now I can estimate. 11 and 9 hundredths is close to 11. This 0 tells me so. 9 and 23 hundredths, this 2 tells me that's close to 9. So if I subtract, I get 2. So my estimate should be close to 2. Oh, guess what? I wrote the problem incorrectly. I'm going to do this over again. We could have just done that one, but I'm going to follow the book. Make sure I don't make any big mistakes. So here is the actual problem that they wanted us to do. And again, this would round to 11, but now this one would round to 2 because it's either going to be 1 or 2, and 8 is bigger than 5, so it's 2. When I subtract, I get 9. 11 minus 2 is 9. So my estimate is 9, so my answer should be close to 9. So 9 minus 6 is 3. I cannot subtract 0 from 8. I have to regroup, so I'm going to take 1 from here and regroup. Now I have 10 minus 8, which is 2. And then I have 10, because I could regroup again, but really this is the same thing. 10 minus 1 is 9. And my answer is close, so it's likely I did not make any mistakes because my estimate shows me that I got an answer that's reasonable. It is now your turn. You can try 9 and 87 hundredths minus 96 tenths, or hundredths. And don't forget to estimate first, and then try 5 and 75 hundredths minus 5 and 5 hundredths. All right. This is where you would pause, you would do these problems, and now I am going to show you how to do that. So this could either be 9 or 10. This shows me that it would be estimating to 10. This is going to be 1 or 0. The 9 shows me that this is estimating to 1. So when I subtract these, my estimate is 9. So when I actually subtract, I have to line up my decimals. 7 minus 6 is 1. 8 minus 9 I cannot do, so I have to regroup. 18 minus 9 is 9. And 8 minus 0 is 8. Well, 8 and 91 hundredths is very close to 9, so I know I got that probably right. Now let's try the next one. 5 and 75 hundredths, it's either going to be between 5 and 6. The 7 tells me that it's going to be 6. Between 5 and 6 again, the 0 tells me that it's 5, so when I subtract these, I get 1. So I should get close to 1 when I actually subtract. So line up my decimals. I can even bring it down here if I'd want to. 5 minus 5 is 0. 7 minus 0 is 7. 5 minus 5 is 0. So 70 hundredths is close to 1. It's likely that I got that right. I could say 70 hundredths, or I could say 7 tenths, because this 0 is a placeholder. All right. If you made any mistakes, it's time to reflect. What do you think you might have done wrong? Did you line up the decimals correctly? These actually have the same place value, so it's easier to line up those decimals when the place value is the same. Did you make a simple mistake when subtracting? Did you forget to regroup? All right. We're moving on. Well, we did addition, we did subtraction, so what do you think is next? If you thought multiplication, you are correct. So now we're going to look at how do we estimate when we are multiplying. So when we multiply, we can round to the nearest whole number as well and get a estimate to see if our answer is reasonable. So this is the same process. So if I had 11 and 97 hundredths times 2, well, I can round 11 and 97 hundredths to the nearest whole number, which would be 12, because it's either going to be 11 or 12, and that 9 tells me that it's 12. And 12 times 2 is 24. So now I have an estimate. I'm not actually going to solve this one. I'm going to move on to another one to show you again. So if I have 2 and 74 hundredths times 4, I can estimate and to see what my answer should look like before I start. So 2 and 74 hundredths would be either close to 2 or 3. The 7 tells me that it's close to 3. 3 times 4 is 12. So if my answer is close to 12, then I know it's reasonable and I didn't make a mistake. So let's try it. 4 times 4 is 16. 4 times 7 is 28, plus 1 is 29. Oh, there's a mistake a lot of us make. Put the 2 down there on accident. But I caught myself. 4 times 2 is 8, plus 2 is 10. So my decimal actually can drop down, or we see that there are 2 places in the decimal place, so I should have 2 places in my answer. Now, is 10 and 96 hundredths close to 12? It certainly is. This is almost 11, and 11 is definitely close to 12. So my estimate shows me that my answer is reasonable. What wouldn't be reasonable? How about 109 and 6/10? If you got something like that, you would know, whoops, I put that decimal in the wrong spot. So that's how this helps us. Your turn. Let's try a couple of these. So we have 66 hundredths times 7. Remember to estimate first. We have 6 and 2 hundredths times 8. And let's do one more. 98 hundredths times 3. This is where you would pause, try the problems out, unpause to find the answers. All right, so if I am going to round this to see if it's reasonable, I'm going to round to the nearest whole number. Well, this is either between 6 and, this is either between 0 and 1. But the 6 tells me that it's closer to 1. So 1 times 7 is 7. I didn't leave myself enough room to do the problems. So I'm going to actually erase this and put it up here so that I can solve. So if I multiply this out, I feel like I'm going to run out of room, but let's see. Can you guys see it? Let me look at my camera. Yeah, you could see it. All right, I'm going to keep going. So if I multiply 6 times 7, I get 42. 7 times 6 again is 42, plus 4 is 46. Carry the 4. 7 times 0 is 0, plus 4 is 4. All right, so my answer is 4 and 62 hundredths. You might say 4, that's so far away from 7. But again, it's still in the ones place. And so I know that that is reasonable. Check. Let's go to the next one. I have, this would round to 6 because it'd either be 6 or 7, and that 0 tells me it's 6. And then it's 6 times 8. And, oh wait, yes, this is getting messy. there we go. 6 times 8, which is 48. And now we know that our answer should be close to 48. So let's try it out. If you could guess, is it going to be more than 48 or less than 48? Let's see if you're right. 8 times 2 is 16. 8 times 0 is 0 plus 1 is 1. And 8 times 6 is 48. So where does my decimal go? Well, I have 2 here, so I have 2 here. Also, my estimate was 48, so I know my decimal is going to have to go there for it to be reasonable. And it is, in fact, reasonable. All right, the last one. 98 hundredths, the 9 tells me that I'm close to 1. I'm going to put it off to the side. Times 3 is 3. So my answer is going to be close to 3. Let's try it. 8 times 3 is 24. 9 times 3 is 27, plus 2 is 29. 3 times 0 is 0, plus 2 is 2. Oh yeah, that is definitely close to 3, and that helped me put my decimal right away. Also, the same rule, 2 decimal places, 2 decimal places. All right, and guess what's next? If you guessed dividing and estimating, you are correct. All right, so when we divide and estimate, it can be a little bit more complicated. But if we know division facts, it is a lot less complicated. So let's look at a problem. All right, so remember we've talked about this before, and we've talked about estimating when dividing. You need to have friendly numbers, or sometimes they're called compatible numbers. So when we estimate a value like 23 and 64 hundredths divided by 3, we don't use our regular old system of dividing or rounding and then that's it. We actually have to use some thinking to make sure if I estimate this and I divide by my divisor, is it going to come out friendly for me and I'm going to be able to do it in my head? Because I don't want remainders. I don't want an unfriendly division problem. An unfriendly division problem would be a division problem that isn't divisible. So, and we should know what that means from our divisibility rules lesson. Okay, so when we do this, remember when we estimate, we look between the two numbers. So this would be 23 or 24, right? That's where we would be putting this number, and then we would choose based on the 6. Well, the 6 tells me 24. 24 just happens to be divisible by 3, but what if it wasn't? Then I'm going to want to look at the two numbers that are divisible by 3 and pick the one that's closest to the number I'm working with. So if I looked at 23, 24 is divisible by 3, and 21 is divisible by 3. So the best way to do this is to think about the multiples. Check out my multiples videos on TikTok, the ones I shared in the lessons. If you look at the multiples of 3, I sing them out, and it's 21 and then 24. 23 would be in the middle. Well, 24 is clearly closer, so that's the one I would choose. So 24 divided by 3 equals 8. So 8 is my friendly estimate. All right, let's try this with a problem we're actually going to divide. So if we have 5 divided by 40 4/10. Well, when I estimate this, my choices, because I have to use what's divisible by 5, would be 40 or 45. Well, I'm going to choose 40 because that's clearly closer. So 40 divided by 5 is 8. So my answer should be close to 8. Well, let's try it. 5 goes into 4 0 times. Oops. Bring down. 5 goes into 40 8 times. 8 times 5 is 40. 0. Bring down. 5 goes into 4 0 times. 0 times 5 is 0. Bring down the 4. And then I'm actually going to add a digit so that I can get at least a hundredths place. So 5 goes into 40 8 times. Well, look at that. My answer is close to 8. And it is, in fact, reasonable. If you are confused why I brought down this 0, it's because now that I've learned how to divide decimals, I'm going to use that trick every time I divide decimals to make my answer longer. And to me, the tenths place just wasn't enough information. All right. Let's try this on our own. So, a little 12 3/10 divided by 3. 17 73 divided by 9. And 20 93 divided by 7. This is where you pause, try it on your own, see if you can figure it out. If you're stuck, you can just watch and learn and walk it through with me. Or you can ask me questions by emailing me or putting it on the doc. All right, so if I'm going to estimate my choice, it has to be divisible by 3. So I would be choosing 12 or 15. Well, this is clearly closer to 12. 12 divided by 3 is 4, so my answer should be close to 4. So if I divide this out, that's so not enough room. I'm going to actually erase these because I want to have enough room, and I'll put them back. All right, so 12 3/10 divided by 3. 3 goes into 12 4 times. 4 times 3 is 12. 0. Bring down 3. 3 goes into 3 1 time. 1 times 3 is 3. 0. So I have 4 1/10. It is reasonable. Same rule applies with division and multiplication. I have 1 decimal place, so I have 1 decimal place up here. All right. All right, number 2. 17 73 divided by 9. So if I'm estimating this, I can choose 9 or 18 because it has to be divisible by 9. Well, clearly it's closer to 18. So if I did 18 divided by 9, that would be 2. So my estimate is 2. And then if I actually divide this out, 9 goes into 17 1 time. 1 times 9 is 9. 17 minus 9 would be 8. And then bring down. Excuse me. And then 9 goes into 87. Let's see, 9 times 10 is 90. So 9 times 9 is 81. subtract, 6, bring down, 9 goes into 63 7 times. 7 times 10 is 63. So 2 decimal places, 2 decimal places, 1 and 97 hundredths is very close to 2. So my answer is reasonable. And last one. 20 and 93 hundredths divided by 7. So again, it has to be divisible by 7. So my choices would be 14 or 21. This is obviously closer to 21. So 21 divided by 7 equals 3. My estimate is 3. When I actually divide it out, 7 goes into 20 2 times. 2 times 7 is 14. Subtract. Bring down. 7 goes into 69. So let's see, 7 times 10 is 70. So 7 times 9 is 63. So 9, 63. 9 minus 3 is 6. Bring down. 9, 63 again. All right. 2 decimal places, 2 decimal places. 2 and 99 hundredths is definitely close to 3. Reasonable. And this helps you put your decimal places in the right spot too. Okay, the last section to learn about, ooh, that was loud, is about estimating when sums by rounding the nearest tenth. So a sum is when we add, and a difference is when we subtract. So let's see, we can also round to the nearest tenth. So let's look at this. 2 and 49 hundredths plus 6 and 54 hundredths. So instead of rounding to 2 and 7, we can actually round to the nearest tenth. So 2 and 4, here's the tenth. So this is where I'm going to round to. This now is the number that's going to tell me, because it's always the number to the right. So that's going to tell me that it's either going to be 4 or a 5. So it's going to be a 5. So this is going to estimate to 2.5. And this is going to estimate to, this is where I'm going. This is going to tell me what to do, 6.5. So now I can add these. 6 and 2 is 8, and 5, half and half is 1. So that is 9, is my estimate. So you can say it's about 9. And then if I was going to add these, 9 and 4 is 13, 5 and 4 is 9, plus 1 is 10, 6 and 2 is 8, plus 1 is 9, and look at that. It is definitely close to 9, and it is reasonable. That is all for this lesson. I would suggest that you go through this and make sure that you understand each part before you go onto the workbook pages. And if you need extra help, you can do the Let's Practice, which is in your hard book. It's page 75. So here, so your assignment is going to be workbook pages 39 to 42. And if you want extra practice, you can try your hard book. The Let's Practice is on page 75 and 76. If you have any questions, you know how to get a hold of me. Thanks for watching.